Pluto made them come all along. Pluto's circle crosses that of another planet. Pluto, the confounding little planet at the external scopes of our planetary group, is working up fervor on the planet of stargazing. Ongoing reports indicate a conceivable experience with Neptune, raising worries among researchers and space fans. Striking figures like Neil deGrasse Tyson and Michio Kaku have sounded alarms about the ramifications of this astronomical event. However, how did Pluto end up on an impact course with its adjoining planet, and what might the heavenly conflict at some point mean for life on Earth? Join us as we unwind how something monstrous just slammed into Neptune and how researchers have been left stressed by this astronomical oddity. Pluto, once hailed as an undeniable planet, went through a change in its status, being renamed as a dwarf planet because of its curious orbit. Regardless of this downgrade, Pluto still dazzles and interests the cosmic community. Ongoing concerns from regarded researchers like Neil deGrasse Tyson and Michio Kaku have raised worries about Pluto's trajectory potentially converging with Neptune's, indicating an approaching string of impact between the two divine bodies, which could have critical repercussions for Earth. Pluto's excursion around the Sun stands out because of its exceptional attributes. Inside our nearby planetary system, its orbit is incredibly extensive, spreading over a stunning amount of time. Since its discovery in 1930, Pluto has yet to complete a full orbit around the Sun. Adding to its persona is the extremely elongated shape of its orbit, a departure from the more round orbits followed by the major planets. Besides, Pluto's orbit deviates by 17 degrees from the ecliptic plane, giving its path a more extreme grade compared to other planets. The mix of Pluto's inclination and its elliptical orbit presents layers of complexity to its orbital pattern. One outstanding aspect is its occasional crossing point with Neptune's orbit. For about 20 years during each orbit, Pluto ventures closer to the Sun than Neptune, opposing assumptions based on their respective positions in the solar system. Digging further into Pluto's orbit, it's intriguing to note that it's not a perfect circle but rather an elongated orbit resembling more of an oval shape. This unique orbit results in significant variations in Pluto's distance from the Sun throughout its journey. At its nearest approach, Pluto comes within around 30 astronomical units, AU, of the Sun, while at its farthest point, it reaches more than 49 Australian dollars away, twice the distance of Neptune from the Sun. Additionally, Pluto's orbit is tilted at an angle relative to the orbits of the major planets in our solar system. This inclination not only adds to the complexity of its orbit but also plays a critical role in its interactions with other celestial bodies, especially Neptune. When Pluto encounters Neptune, their gravitational pulls affect each other, altering their trajectories over time. The complex dance between Pluto and Neptune highlights the dynamic nature of our solar system. While Pluto was once considered a solitary wanderer in the outer reaches, its periodic encounters with Neptune underscore the interconnectedness of celestial bodies, each exerting gravitational forces that shape the orbits of others. Lately, advancements in observational technology have allowed astronomers to track Pluto's movements with greater accuracy. This has led to a deeper understanding of its orbit and its potential implications for the stability of the outer solar system. While the likelihood of a direct collision between Pluto and Neptune remains low, the possibility cannot be entirely ruled out, prompting continued observation and study by the astronomical community. Despite its modest size and remote location, Pluto continues to command attention and interest among scientists and enthusiasts alike. The question arises, why hasn't there been a collision between Pluto and Neptune? The answer lies in the gravitational pull of other planets. Astronomers began studying Pluto's orbit shortly after its discovery, and its path puzzled them. Unlike most planets that lie close to the same plane as they orbit the Sun, known as the ecliptic plane, Pluto stands out with its steep inclination and oval-shaped orbit. The mystery deepened when they realized Pluto's orbit crosses Neptune's. Despite these complexities, Pluto's orbit remains stable, demonstrating the intricate mechanics of space. Understanding how three celestial bodies, Pluto, Neptune, and the Sun, interact gravitationally is a major challenge. It's like trying to predict where they'll go based on where they start and how they pull on each other. For Pluto, this challenge reveals how its orbit, Neptune's orbit, and the Sun's gravitational effects all work together in terms like asymptotic libration, latitude libration, and the ZLK oscillation. These concepts help researchers address the grand cosmic puzzle. Asymptotic libration is crucial for keeping planets in their orbits. When Pluto crosses Neptune's path, it's always around 90 degrees away, preventing a collision. Latitude libration ensures that when Pluto approaches Neptune or other large planets, it's well above their path, reducing the chance of an impact. The ZLK oscillation, named after researchers von Zeipel and Lasker, explains why Pluto's orbit appears odd but remains stable over time. In the midst of space confusion, certain patterns and rules keep things together. These principles keep Pluto's orbit stable, preventing collisions with Neptune or changes in its path. The concept of orbital chaos, which shows how a celestial body's orbit is highly sensitive to its starting point, is well illustrated by Pluto. Even small changes in its position or speed can alter its orbit over time. Researchers use computer simulations to understand how Pluto moves in space. These simulations use complex mathematics to show how Pluto interacts with other celestial objects like Neptune. By tweaking these simulations just a little, astronomers can see how small changes can modify Pluto's orbit. In the late 1980s, these simulations revealed something intriguing about Pluto's orbit. Despite factors that should make it stable, Pluto's orbit can still be unpredictable. Even a small difference in where Pluto starts or how fast it's moving can cause significant changes over many years. However, despite this chaos, Pluto's orbit remains stable for a remarkably long time, like billions of years. This suggests that even though Pluto appears chaotic, its journey around the Sun follows some kind of order. Predicting what will happen with planets like Pluto, which have irregular orbits, is challenging. These systems are so erratic that it's difficult to figure out what will happen over the long term. Simulations help us learn about potential future scenarios, but they also show that we can't predict everything perfectly. These models require careful starting points and simulate complex dynamics. Indeed, even a small error can lead to entirely different outcomes, making precise predictions difficult. Understanding Pluto's orbit is crucial, especially when considering the possibility of a collision with Neptune in the future. This knowledge helps us better understand how our solar system works. Pluto's orbit shows us how orbits that seem chaotic can stabilize due to gravity and how objects move in space. It's important to continue observing and studying these phenomena to understand where we fit in the universe. When we explore space, we discover that things can be unpredictable, and Pluto's orbit is a great example of that unpredictability. Pluto's orbit is not like those of the other planets. It's more oval-shaped, which means it's not a perfect circle. Sometimes it even gets closer to the Sun than Neptune does. This can create interesting scenarios because Neptune is also on a different path. There's a small chance that Pluto and Neptune could collide eventually. However, despite its unusual orbit, Pluto manages to keep its distance from Neptune most of the time. This is due to something known as gravitational forces. Gravity acts like an invisible force that pulls things toward each other. So even though Pluto and Neptune might seem like they're on a collision course, their orbits are carefully arranged and influenced by gravity. Pluto's orbit teaches us that space is full of surprises. What seems chaotic at first can be a delicate balance of forces. By studying Pluto's orbit, researchers gain insights into the intricate mechanics of our solar system. This ongoing observation and investigation are essential for expanding our knowledge of the universe and our place within it. Imagine if Pluto and Neptune did collide. It would be a monumental event, sending shock waves through our understanding of the solar system. While we've made progress in understanding space, this scenario shows that we still have a lot to learn. Studying how large planets affect Pluto's orbit gives us valuable clues about how our entire solar system functions. It shows us that where each planet is and how it moves can change the orbits of other things in space. Despite the complexity of space, some leading scientists worry that Pluto could collide with Neptune. This makes them wonder why such a collision might happen, even though it seems unlikely. Neil deGrasse Tyson, a renowned astrophysicist, has interesting ideas about Pluto. He believes that renaming Pluto as a dwarf planet, rather than a major planet like Earth, is a step forward. He thinks we are continually learning new things about how objects move in space. Tyson views Pluto's unusual orbit as a sign that there's still much we don't know. He finds the mysteries of space fascinating and believes that significant events, like Pluto's renaming, spark public interest in astronomy. Tyson aims to help people understand the cool and sometimes strange aspects of space mechanics. He collaborates with other researchers to warn people about the potential risks of Pluto's odd orbit. After studying Pluto extensively, he is concerned that it could collide with Neptune one day, which could pose significant problems for our entire solar system. A collision between Pluto and Neptune would be a fascinating and dramatic event. It would release a lot of energy and could cause fragments of Pluto to scatter into space, potentially hitting other planets and moons. Neptune could also feel the impact and change its movement. Renowned theoretical physicist Michio Kaku believes that if Pluto and Neptune were to collide, it would be a spectacular and intriguing event. Kaku sees such an occurrence as a valuable opportunity for researchers to gain insights into the dynamics of our solar system. He suggests that while the probability of such a collision is very low, the potential knowledge gained from studying such a rare event could be invaluable. Kaku emphasizes that this would not only help us understand the mechanics of planetary orbits, but also provide deeper insights into the formation and evolution of our solar system. Kaku also believes that the scientific community should continue to monitor Pluto's orbit closely to ensure we are prepared for any unexpected changes. As we advance our observational technologies, Kaku argues that we are continuously uncovering new aspects of our solar system that challenge our current understanding. Despite the low likelihood of a collision, Kaku advocates for ongoing research and vigilance, as even small changes in our celestial neighbors' orbits can have significant implications for our knowledge of the universe. To fully appreciate the complexity of Pluto's orbit, it's essential to understand the various forces at play within the solar system. The gravitational influence of other celestial bodies, such as the gas giants Jupiter and Saturn, also affects Pluto's orbit. These giants exert significant gravitational forces, which can subtly alter the trajectories of smaller objects like Pluto. This is a prime example of how interconnected the solar system is. Even distant bodies can influence each other's orbits through gravitational interactions. Jupiter's immense gravity, in particular, can send ripples through the orbits of nearby objects, sometimes altering their paths in unexpected ways. In addition to gravitational interactions, the presence of other trans-Neptunian objects, TNOs, and Kuiper Belt objects, KBOs, adds further layers of complexity. The Kuiper Belt is a region of space beyond Neptune, populated with numerous icy bodies and dwarf planets. The gravitational influence of these objects can contribute to the perturbations in Pluto's orbit. Studying these interactions helps researchers understand not only Pluto's orbit but also the broader structure of the outer solar system. One captivating aspect of Pluto's orbit is its relationship with the solar wind, a stream of charged particles released by the Sun. Although Pluto is far from the Sun, the solar wind still affects its atmosphere. When Pluto's orbit brings it closer to the Sun, its atmosphere can expand due to increased solar radiation, making it more dynamic. This interaction is part of what makes Pluto such an intriguing object of study. The way its atmosphere responds to solar changes provides insights into how distant celestial bodies interact with their local space environment. Furthermore, Pluto's relatively recent flyby by NASA's New Horizons spacecraft in 2015 provided a wealth of data that continues to impact our understanding of this distant world. New Horizons captured high-resolution images and collected various measurements of Pluto's surface and atmosphere, revealing fascinating details such as vast ice plains, towering mountains, and even potential signs of cryovolcanism. These discoveries have reshaped our views of Pluto, showing it to be a dynamic and geologically active world rather than a static frozen relic. The implications of Pluto's complex orbit and its interactions with other celestial bodies extend to our understanding of celestial mechanics. The study of such interactions contributes to the broader field of dynamical astronomy, which investigates how objects move under the influence of gravity. By examining the intricate dance between Pluto, Neptune, and other solar system bodies, researchers gain insights into the principles governing orbital mechanics and stability. This knowledge is crucial for predicting the future movements of celestial objects and understanding the long-term evolution of planetary systems. In terms of planetary defense, studying objects like Pluto is also important. While Pluto itself poses no threat to Earth, understanding the behavior of small bodies in the solar system helps researchers develop strategies for monitoring and mitigating potential threats from other objects. The principles learned from studying Pluto's orbit can be applied to track near-Earth objects, NEOs, and predict their future trajectories. This is part of a larger effort to protect Earth from potential impacts by asteroids and comets. The scientific community remains vigilant in its observation of Pluto and other distant objects. Future missions and ongoing observations will continue to refine our understanding of Pluto's orbit and its interactions with the solar system. Upcoming space missions, such as potential missions to other Kuiper Belt objects, will provide additional data that could reveal more about the early solar system and the formation of planetary systems. In addition to its scientific significance, Pluto's story also highlights the role of public engagement in astronomy. The renaming of Pluto as a dwarf planet sparked widespread interest and debate, demonstrating how scientific discoveries can capture the public's imagination. Educational programs and outreach activities focused on Pluto and similar celestial objects help foster a greater appreciation for the wonders of the universe and inspire the next generation of scientists and explorers. Overall, the study of Pluto's orbit and its potential interactions with Neptune offers valuable insights into the dynamic nature of our solar system. By continuing to explore and monitor these distant worlds, researchers enhance our understanding of celestial mechanics, planetary evolution, and the broader cosmic environment. The ongoing research into Pluto and its interactions with other planets underscores the complexity and interconnectedness of the solar system, revealing a universe that is both fascinating and continually evolving.